Hello, welcome to m252, Calculus 2 here at Cañada College. My name is Lapuz. In this video, we'll be doing checkpoint 5.17 from section 5.4. This is a section for comparison tests. It says use the limit comparison test to determine whether the series converges or diverges. And this is our series. This is a sum from n goes This is a sum as n goes from 1 to infinity of 5 to the n divided by 3 to the n plus 2. Now, in terms of comparison, we want to compare this to something that we know converges or diverges. And in using the limit comparison test, we'll take the ratio of those two and then see if we get a constant or 0 or infinity. And then depending on how you put the ratio, it depends on what your result is. So if we get a number between 0 and infinity that's not either 0 or infinity, like a finite number, then finite non-zero number, then the two series will be doing the same thing. Either they'll both converge or both diverge. All right, now what are we going to compare it to? I think this plus 2 here is pretty insignificant in terms of what happens in the big picture. So let's think about comparing it. Compare with the series 5 over 3 to the n. So this is, we see the 5 to the n up on top, and 3 to the n is a significant term in the bottom. And like I was mentioning, 2 is not really that significant. So you put that together into this. This is a geometric series. And this is a geometric series where r is equal to 5/3, which is clearly bigger than 1. So the fact that it's bigger than 1 means that the series diverges. So we're going to compare this with a series that diverges. And if we take the limit comparison test, if we take the limit as n goes off to infinity of the ratio of them, ratio meaning put them as a fraction, and if that comes out to be a non-zero finite number, then they'll be doing the same thing, which means the series is going to diverge. So let's take the limit as n goes off to infinity, and let's put this 5n over 3n plus 2 in the numerator. And let's put this other series 5 over 3 to the nth power in the denominator. All right, so we know that we're dividing fractions. We can multiply by the reciprocal, 5 to the n over 3 to the n plus 2 times, and then I'll split this up like written over here, but I'll also take the reciprocal, 3 to the n over 5 to the n. And as we multiply, this is going to cancel, and we can write this. I mean, they don't exactly cancel, but if we rewrite that as limit as n approaches infinity of 1 over 3 to the n plus 2 times 3 to the negative n, then we can see that being distributed. Limit as n approaches infinity of, now this 3 to the n times 3 to the negative n will just be 1. That'll be 3 to the n minus n in the power, which is 3 to the 0, and that's equal to 1. And we'll have 2 times 3 to the negative n. Now we can take the limit, and what happens when we take the limit here, limit as n goes off to infinity, this whole thing is going to go to 0, so 2 times 0 is 0. And all we're left here is equal to 1. So 1 is a finite non-zero number. So this means that whatever this series does, what we compared it to, then this series is also going to do. So let's write that out. Since our compared series 5/3 to the n diverges, then so does the series 5 to the n over 3 to the n plus 2. Okay, so this thing diverges, and that's your result. I hope that helps.